record. What we're going to learn about in 6.1 is frequency tables and histograms. This is by far one of the easiest lessons that we are going to have. You're going to enjoy 6.1 because it is so simple. Before we start with how simple this is, let's define a few words. The first word I want you to know is the word frequency. Frequency. Our essential question is, how do we create frequency tables and histograms? So the first thing I want to define is the word frequency. When I say the word frequency, I want you to think of the words how many. The word frequency, let me underline it because that's kind of what we're defining right now, is dealing with a how many. If I say, what's the frequency of times that people go through an intersection? How many times do they go through the intersection? You would just be counting. Frequency is a fancy word for how many. Okay? A histogram, let's figure out what that is. Histogram, in other words, is a fancy word for bar graphs with no spaces. Histograms are bar graphs with no spaces. The last word that we're going to define is interval. Interval, that I'll be using quite often. Interval is the size of your categories. The size of your categories. Once we use or learn these three words, then we're just going to end up making frequency tables and histograms. And I'll show you how it's done, and then we're going to define the different types of histograms that you're going to need to know the difference of. Okay, before I even get into it, why are we going to learn this? Because we are going to learn how to organize data. This is I'm going to put a little star why we are doing this. We are doing this because it's a way to organize our data. We're going to have a bunch of information. I'm going to tell you a bunch of numbers. And one of the best ways to organize your data or your bunch of numbers is to put it into a frequency table or a histogram. And I think the easiest way for me to show you how this works is to give you a real world example. Okay? Let's do it like this. I'm going to start off with a frequency table. Here's my frequency table. Let's write that down. Frequency table. Underline. This is my frequency table example. Fancy words. A how many table. I'm going to ask a few of you some questions. When I answer, or when I ask a question that involves you, I'm going to make sure everybody's involved today. But I have to start with the youngest. The youngest person in this classroom is Ray. Ray, how old are you? 12. How old? Yeah, 12. Perfect. Okay. I am going to start off with 11 and 12-year-olds. So let me put this down. 11, 12. That's an interval. And then I'm going to go into the next age group, which will be 13 and 14-year-olds. And then I'm going to go into 15 and 16-year-olds. Is there anyone in here who's older than 16? I think my senior left first semester. He only did first semester. Okay. Then there's a couple of teachers in here, and we're just going to put in here, let's say, in our 30s. That'll be fun. That'll be fun. You're not? Okay. Oh goodness, I'm almost in my 40s. Okay. By the way, let's lie and say 30s, right there. Okay. No. Let's not even include us teachers. They're only going to do students. Student ages. That's so much better. Okay, here we go. A frequency table, ages. This is how many table. These, and I'm going to put a little arrow over here. These are our intervals. These are our intervals. An interval is the size of our categories. I didn't just include the 11-year-olds. I said the 11 and 12-year-olds. There's 2 in this interval. There's 2 in this interval. I want you, when you're making frequency tables, to have the same size intervals. Notice I wrote that. Same size intervals. 2 age groups there, 2 age groups there, 2 age groups there, which is what I wanted to do. Which is why I kind of skipped Mr. Paramo's age, Miss Piccolo's age, because we're kind of way far away from you guys as far as ages go. Now, frequency means how many. Okay, if you are 11 or 12 years old, please raise your hand. 1. That's how many we have. That's a frequency. If you are 13 or 14, please raise your hand. 1, 2, 3. Okay, high, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's what we're going to write down. We have 17 13 to 14-year-olds. If you are 15 or 16, please raise your hand. Nice and high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Perfect. There we go. What you just did was you created a frequency table. You can now see, 1, the youngest age group in here. You can see the oldest age group. You can see how many are there. It's a lot easier, instead of me going like this and saying, how old are you? 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 Imagine if I did that 34 times. Think about that. If I were to go 34 times and ask how old are you, you're going to get somebody say 13, somebody's going to say 14, one person's going to say 11 or 12. 16 people are going to say either 15 or 16. If I wrote all those things down, it would look something like this. 12, 14, 13, 15, 16, 14, 16. Imagine having data that just looks like crazy. How are you going to make it make sense? A frequency table should organize the data. Does that make sense? It's supposed to make it easier to understand. As a matter of fact, with something like this, you can tell how many students we have here today. Do you know how many students we have here today just by looking at this frequency table? 44. Exactly. It makes the data easier to understand. That's the first goal of a frequency table. Okay? Now, this is a frequency table. Let's switch over to something called a histogram. Let's write that down. Histogram. A histogram is like a bar graph. It's presented in a slightly different way. Instead of us having the intervals on the left and the how many, this is called the frequency. Let me go back there and put frequency at the top of this column. A histogram has the intervals on bottom. So they go like this: 12 and 13-year-olds, 14 and 15-year-olds. Is that what I did? Dang it. Whiteout. That's what that's for. That didn't make sense because I was like, hey, what happened there? 11 and 12, 13 and 14, 15 and 16. Notice I have these little lines here because I don't have any spaces there. So here's what I do with a histogram. I look and see how many I have. How many is my biggest number? My biggest number is 17. So that means I need to count up to at least 17. And I have to make an educated decision. This is where I'm going to give you the freedom. What do you want to count by? You have to get to 17. Don't count by ones, please. What should we count by?
Threes.
Threes? Maybe. Let's make it easier than that. What do you want to count by?
Well, can't you make like a little like a break thing in the graph?
You could.
So if you go up by ones, but then like you just have like go up like one and then a little break.
We can't. As a matter of fact, our textbook will even do these little wavy lines like this if it does a break. But if I were you, make this easy on yourself. You can make the top 17. You could go by tens. You can go by fives. It doesn't matter. Just make it easy on you. For me, what I'm thinking is that I might put 17 right here at the top. Right, that line. Okay? I'm making it nice and easy. Now, how many 11 or 12-year-olds do we have? So this is going to be a bar, and the bar is going to be our very thinnest bar at the bottom. If I want to, I could put a 1 there, or we can just estimate what it is because it doesn't have to be exact. How many 13 or 14-year-olds do we have? So we're going to go all the way up to the 17. And I usually like to color it in so I can see what it's like. Notice there is no space between our 11 and 12-year-old group and our 13 and 14-year-old group. No space. And 15 and 16-year-old group. So do I go up as high? So I just need to make sure it's not the same height as the one before. And sometimes I will color it in a slightly different direction so I don't get confused as to which one is which. And of course, you could go in every single line if you wanted to, but histograms is just a way to see the data. This is good for people who like the numbers. This is good for people who like a visual graph. When I show you grades, when I went over the Unit 5 test scores, I tried to give you a histogram. It spaces them out. Histograms are with them together. Okay. Does that make sense to you so far? Pretty simple stuff, right? Okay, there are types of histograms. Types of histograms. Like categories, if you will. There's uniform. There's skewed. And there's symmetric. sometimes we are going to ask you what is the data uniform, skewed, or symmetric? And you're going to have to decide. So uniform is when it's roughly the same size. Roughly the same size. I'll give you an example. If you had a histogram and the histogram was roughly almost all the same size, they were almost all the same size categories, that would be a uniform type of graph. If we were saying a skewed graph, think of a skewed graph as lopsided. There are more either on the left side or there's more on the right side. It's a lopsided graph. What I like is I like to have a skewed histogram in this class. Let me show you what I mean. For me, I like to have graphs that look like this. Very, very few F's and D's, and what I like to have are lots of B's, and lots of A's when I show you a bar graph. Skewed, it's skewed right or skewed left, and it's actually, if we were to get technical, if you want to go into stats your senior year, it's skewed. And depending where the least amount is, that's what you say. It's skewed left, like wherever the tail is of this data. Ray, do you have a question?
No, yeah.
Okay. Last one is symmetric. I want you to think of symmetric as where it's balanced, where it's centered. So if I see a symmetric graph, it's going to look like where it is balanced on the left and the right hand side, where it almost looks like the right and the left are totally symmetrical. Like I could draw a line down the middle and fold it, and the right side would match the left side. Those are symmetric. So if I give you an example, if I do a graph, you should be able to tell which one is which. I'm not going to give you an example. I think you're going to be able to do that with your notes out and open like that. The last thing we need to cover, and then we'll be done with our notes, is this one last word, cumulative. Cumulative. Frequency table. Cumulative. That's one of those hard words for me to say. Cumulative. I don't know. It just doesn't flow right with me. That's just, I don't know. We don't use this word very much. But you will if you start worrying about your GPA. Your GPA, when you apply to colleges, a lot of times you use your cumulative GPA, meaning all the years together. What's your GPA? Your freshman year, your sophomore year, your junior year, your senior year. Your cum for short. That is very common to talk about your senior year. All right. Cumulative frequency table is where we add everything together. So let's do an example of a cumulative frequency table. Let's see. I'm running out of room, but this should still fit. Number. Mute. Number of siblings. Number of siblings will be our first column. Frequency. Cumulative frequency. Cumulative frequency table. It has a third column. So it's going to be very similar to our frequency table that we had before, except there's a third column added to this. I'll give you an example. Let's do some categories here. 0 to 1. You have 0 siblings. You have 1 sibling. If you don't know what a sibling is, that means a brother or a sister, or even a half sister. We can count those, or a step sister or step brother. Those count. I'm sure they affect your life somehow. Okay, 0 to 1, 2 to 3. I'm curious, anybody have 4 or more siblings or step siblings? Thank you. Do you have more than 5? Keep going. How many?
I have 8.
Oh, okay. Let's see. We'll just go like this. 6, 7, 8, 9. Okay. We're gonna catch up to Cassie. So just like before, all of you are going to fall into this category, right? One of these categories. My intervals are the same size. I'm going to make sure I talk about intervals are the same size. And guess what? You can pick it. Instead of me doing 0 and 1, I could have done 0, 1, or 2. I could have made my categories bigger had I known we had a Cassie in the family, right? It's okay. Let's see how this pans out. I have no idea what this is going to look like because I don't know how to organize the data, but let's see how it goes. If you have 0 to 1 siblings, please raise your hands nice and high. No. Only 0 to 1 because you're higher. You're higher than 1, 2, 3, 4, 5, 6, 7. Let's write down 7 for our frequency. So what is our cumulative frequency? How many have we counted so far? That's what this means. How many have we counted? How many have we counted so far? That's what this last category means. We've counted 7 so far. Or what's the total amount that we've counted so far? Now 2 to 3 siblings. You have either 2 or 3 siblings. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Woo! That's a big category right there. 25. How many have we counted so far? What goes here for your cumulative frequency? 32. You have the 25 we just counted plus the 7, which makes 32. That's the difference. We're going to keep a total amount that we know so far. How many people have 4 to 5 siblings? Raise your hand. 1, 2. Thank you. What's our cumulative frequency? 32 plus the 2. Anybody with 6 to 7? 0. What's our cumulative frequency? And then 8 to 9? Guess it. And what's our cumulative frequency? That's how a cumulative frequency table works. You can now see how many total there are. So our biggest category, 2 to 3 siblings. If we were going back, since this is our biggest, sometimes we could split it up if we wanted to, but right now this is perfect. Let's end our notes right there.